Yeah,
All right.
I think they control it.
On to our final session, an especially timely science in the news session. We will explore the topic of gene drive. We'll learn together what that term means and what the technology could mean for the world. We are very lucky to have Fred Gould, a professor of agriculture at North Carolina State University, who was once a New York City cab driver and is an avid swing dancer. All right, we have Pam Belluck, who is a health and science writer for the New York Times, and who, in college, played ultimate frisbee. Finally, I think you'll find it pleasant to listen to Dominique Brossard, chair of the Life Sciences Communication Department at the University of Wisconsin-Madison. So she will summarize at the end research findings about communicating gene drive.
Thank you so much. So last year, when the National Academies endorsed continued research on gene drive, our New York Times article about the recommendation generated a number of reader comments. And here's one. "This will only have one outcome," wrote a reader from Massachusetts, and it's not bad. "It'll be horrible, beyond all belief, but they will not know that for many years. Mankind's God complex is completely out of control." That fit? Trying to get the button. There we go. Okay. And Mary from Atlanta was pretty clear. She said, "Please stop. We all die someday and no good will come of gene drive." But there were also supporters. A Minneapolis reader wrote, "The Academy suggested that more work must be done. What kind of illogical arguments must be used to stop this work? Only ones based on fear and ignorance of basic scientific principles. Let the experts experiment." I like this reader with the handle Days. It's not working. I see. Got it. Okay. Who said, he took sort of the scare, I'm assuming it's a he actually, he took the scare tactic approach. "Once the Earth's temperature rises a little more and Zika has firmly set root in the US and the microcephalic children are counted in the thousands, excessively worried technophobes' attitudes will change towards this potentially misery-reducing technology. Until then, try not to watch Jurassic Park." And this reader thinks it's just going to backfire on science itself. You know, finally, with gene drive, we have a means to generate profound hatred of science and scientists. So with that level of passionate debate in mind, I'm going to talk about one case where the idea of gene drive has been raised, and then I'm just going to mention some news which developed in this field just yesterday, and Fred is going to talk a little bit more about that. So the case concerns ticks, Lyme disease, and Nantucket. And it's interesting both scientifically and from the standpoint of public communication. Lyme disease is the most common vector-borne disease in North America, and Nantucket has long had one of the highest rates of Lyme. And I've spent some time following one of the people trying to battle Lyme disease, Dr. Tim Lepre, who's this sort of eccentric but essential jack-of-all-trades doctor on Nantucket, and he's kind of a self-styled Captain Ahab against an enemy that I started to call Moby Tick. And you can see him here. He's with his pet red-tailed hawk, Ajax, and he's wearing a shirt that says Nantucket, which I think he special ordered. So Nantucket, when you start thinking about possible man-made solutions to a problem like tick disease, it's interesting to note that Nantucket's tick problem is actually partly man-made. In 1922, a deer was found swimming in the ocean, and a fishing boat picked up the deer and brought it to Nantucket, which at the time had no deer at all. And the islanders named the deer, and they called it Old Buck, and they didn't want him to be lonely. So they enlisted the help of a former ambassador and some other dignitaries, and they imported 2 does from Michigan, and the does got together with Old Buck, and they did what bucks and does do. And now, Nantucket has about 60 deer per square mile, which is a lot. But where are they going to go? It's an island, and most of them don't seem to have inherited old buck's ability to swim. So I'm talking about deer because they're important to the tick life cycle, because they often provide the blood meal and the mating launching pad for adult ticks. So that's why there are frequently proposals in areas like this to kill some deer, and those are controversial proposals. One of the things that Dr. Lepre does is he swoops down on deer that hunters kill, and he picks ticks off of them, the deer, not the hunters, and he packs them into a vial that he always carries with him. Then he sends the ticks off to the mainland and has them analyzed for tick diseases. Okay, so that's the background of Nantucket's situation. Lots of debate over whether to kill the deer or not kill the deer. But it turns out deer are only one player in the Lyme disease game. Another crucial player is the white-footed mouse. And the mice, they get infected with Lyme, and then when ticks are still in the larval stage, they often get their first blood meal from the mice. So if the mice are infected, the tick larva gets infected, and then it can transmit Lyme disease to humans when they bite again. So I want to say some of the slides and photos in my presentation come from a bunch of different sources, including Stat, N Magazine, The Atlantic, one or two health department websites, and some studies. So enter Kevin Esvelt, an evolutionary biologist from MIT and a gene drive researcher. And his team has been able to isolate DNA sequences from anti-Lyme antibodies. And they believe it will be easy to edit those sequences into mouse genomes and produce mice that are resistant to Lyme disease. They're also working to isolate DNA sequences from antibodies to a protein in tick saliva. Essentially, it would be anti-tick antibodies, which would help protect the mice against other tick-borne diseases like babesiosis. So this is Kevin Esvelt. So Kevin Esvelt's original discussion with Nantucket included a version of gene drive. That's because gene drive is more effective, it works faster than regular genetic engineering. If you do regular genetic engineering, you make a change to one copy of a gene, and then there's a 50-50 chance it's going to get passed on to the next generation. With gene drive, which is a genetic change that's made, and Fred's going to explain in more detail, but basically it's made via CRISPR. It involves changes to both copies of a gene, so the change would almost always be transmitted to the next generation of mice. Then the disease-resistant mice would spread quickly on the island, and that would prevent a lot of tick disease transmission. Now, there are different types of gene drive, and the type that Esvelt discussed with Nantucket would be localized, he told me. It wouldn't self-propagate through every generation. I'm going to let Fred talk more about the different types. But Esvelt has also been doing something rather unusual in science, allowing the community to decide how and whether he does anything at all to the mice. He's made presentations on Nantucket and also on Martha's Vineyard, which has a similar situation. He's formed steering committees that very deliberately include skeptics and critics. He publishes his plans online. He solicits lots of feedback. He's repeatedly said that if Nantucket or Martha's Vineyard say no, he and his Lyme-resistant DNA will bow out. And it's an approach that, because it's unusual, has attracted the interest of a number of journalists, so Esvelt has been getting some attention. Well, the people of Nantucket and Martha's Vineyard have said they don't want gene drive. That's because gene drive requires the introduction of some additional bacterial genes into the mouse genome. So it wouldn't be simply DNA from the mouse, but it would add something that would be, in the view of some islanders, non-mouse. And that's not comfortable for some of the people there. And they're also concerned that gene drive could unleash knock-on effects that would be undesirable. Now, the news yesterday was that Esvelt and colleagues published a perspective piece and a mathematical model that basically said, whoa, scientists should put the brakes on many applications of gene drive. And he told my colleague, Carl Zimmer, who wrote about this for the New York Times, that his previous suggestions of certain applications for gene drive were, quote, an embarrassing mistake. And he said, I feel like I've blown it. Now, in this new work, he was specifically talking about using gene drive for a different kind of application, for conservation, to control invasive species like rats in New Zealand by introducing a gene that reduces fertility. This was something he suggested a few years ago with a diagram that made it seem like lots of gene drive applications were possible. Looks like everything can be done here. What the new mathematical model suggested was that the gene drive spreads really, really fast, even in places where the species isn't invasive, so it almost becomes an invasive species itself. And in the perspective piece, Esvelt wrote, now is the time to be bold in our caution. Now, some other scientists in the field, like Fred, think it's too early to say that the consequences would be so dire. And Esvelt still says that gene drive might have applications for a plague like malaria. And he's been working on a version of gene drive that would sort of peter out after several generations, plus the version that he talked about on Nantucket, which would be sort of localized to a specific geographical place, like an island. And there are other scientists who are working on versions like this too. But right now, gene drive is off the table on Nantucket and Martha's Vineyard. And instead, what Esvelt's doing is working on sort of a regular genetic engineering approach where he would release a colony of mice, about 50,000 on each island, and that would spread to the next generation, the change about 50% of the time. And he plans to test this in about 4 years on an uninhabited island, and then if after a couple of years it seems to work and reduce tick populations and doesn't have any bad effects, he would take it back to Nantucket and Martha's Vineyard. And here he is having a community meeting on Nantucket. And the community is going to have to say yes at every step of the way. And Dr. Lepre tells me that he thinks there's a good chance they'll agree to the non-gene drive genetically engineered mice, in part because they have appreciated Esvelt's openness with them. In fact, Esvelt recently told the public radio station in Boston that, he said, frankly, the world could use a salutary example of a community saying no and the researchers actually walking away. He said we could probably use that example to build public trust in science right about now. Now, we've been talking a lot about the need to build public trust in science, and obviously some of the comments of New York Times readers reflect that too, so I'm just going to finish up with a few more to give you a sense of the range of some of our readers. We have some people who are very literary, not surprisingly. One quoted Robert Burns' line about the best laid schemes of mice and men often go awry. Another literary reader warned against human beings playing the sorcerer's apprentice. Two readers supported their pro and con points with examples from the Middle Ages. Now, we also had a reader from New York who saw a welcome application, cockroaches. And here's a reader whose point would probably resonate with people on all sides. There's one species that truly needs management, and it's not a mosquito. Thank you.
Thank you very much.